Hello, today we are going to be talking about degrees and radians. Today's date is, of course, today. And our objective, we're going to convert between radians and degrees, vice versa, find coterminals of angles, and find arc lengths. So 3 things we want to accomplish today. All right, let's just take a second and talk about angles. You've all had geometry, so when I talk about an angle, you can picture that the initial side is going to be along the x-axis, the terminal side is going to be some ray, and our vertex is kind of like the little point, the little corner. And when I talk about it in standard position, it's always going to start on the positive x-axis and go counterclockwise. Positive angle, counterclockwise, negative angle, clockwise. We've seen this before. We know that a circle has 360 degrees. So this one that we have right here is 45 degrees. And I think when a lot of us, when we picture angles, we kind of think in degrees. But there's actually going to be a second way that we can think of angle measurements. And those are radians. And they're telling us the same thing. They're telling us the measurement of an angle. Kind of the analogy that I think about it is distance. I can either measure distance in miles or kilometers. They can mean the exact same thing. It's just a different way of reporting it. And if I were to say the radius was 1, and if I were to find the circumference around that circle, it's going to be 2 pi, because circumference is 2 pi r. And that's going to be kind of the basis of how we convert between radians and degrees. Okay, again, remember, radians is just another way of measuring an angle. So, if I were to want the measure in radians, it's the theta is the measure around, kind of saying that awkwardly. I don't know that this picture is doing it justice, but if I were to look at this picture and if the radius were 1, it would be 2 pi around. So theta is just kind of going to be a fraction of that circumference. And I'm going to go ahead and give you that conversion. To convert between degrees to radians, you're going to multiply by pi over 180. Because we know 2 pi, that's radians, equals 360 degrees. And if I were to divide that by 360, that's where that pi over 180 comes from. Okay? So 1 degree is 1 pi over 180. Conversely, to convert radian measures to degrees, you're going to multiply by 180 over pi. You will want to convert that to memory, or commit that to memory. All right, pi over 180 and 180 over pi. Let's go ahead and do a couple examples. So on this one, I want to write 135 degrees in radians as a multiple of pi. When it says that it wants it as a multiple of pi, pi is going to be in our answer. That means that we want it exact. We don't want it rounded. We don't want to take pi as 3.14. And this is going to be pretty easy to do. I take that 135 degrees and I'm going to multiply it by 180, or pi over 180. Well, I'm actually going to think of that as 135 over 1. Numerator times numerator, denominator times denominator. You can cross cancel if you want to. 45 goes, or 135, 45 can be divided in there 3 times. 45 can be divided into 180 4 times. So I'm going to end up with 3 pi over 4. So 135 degrees is 3 pi over 4. And if you notice, we always use our degree symbol. You do not use that for radians. That's how you can always tell whether or not they are giving you degrees or radians. Let's go ahead and do a negative. So we've got negative 30. Take a second and ask yourself, is this going clockwise or negative clockwise? Negative clockwise. Is this going clockwise or counterclockwise? It would be going clockwise. But we're going to do the same thing. 30 degrees multiplied by pi over 180. 30 goes into 30 1 time. 30 goes into 180 6 times. Numerator times numerator. Denominator times denominator. I'm going to get negative pi over 6. And if I kind of wanted to visualize that, there's my axis. We'll do it in red. My initial ray would be on the positive x-axis, and I'm going clockwise 30 degrees. And that's what it would look like. All right, on this one, we're going to convert between degree and radians. So they're giving us 2 pi over 3, and they're giving us this measurement in radians, and we need to convert it into degrees. So all I'm going to do on this one is multiply it by 180 over pi. And what's nice on this, my pi's cancel. 3 goes into 180 60 times. 2 times 60 is 120. So I'm going to be left with 120 degrees. And if I were to visualize that, it would start on the positive x-axis. It's going to go counterclockwise. And that would probably be about approximately 120 degrees. On this one, we've got a negative. So we're going to take negative 3 pi over 4, convert it into degrees. We're going to again multiply that by 180 over pi. My pi's cancel. 4 goes into 180 45 times. 3 times, or negative 3 times 45 is going to be negative 135. Looks like missed a negative sign right there. All right, take a second, pause, try this one on your own. If you circled C, you got it correct. You're going to multiply that by pi over 180, reduce your fraction. All right, coterminal angles. Coterminal means that they're going to have the same terminal side. They'll have the same initial side and the same ending side. Let's take a second and see what that looks like, okay? So I'm going to go ahead and just draw an angle. And let's draw that in red. Okay, so I've got an initial side here. Oops, that was supposed to be an arrow, but that's okay. And then I'm going to have my terminal side right here. Imagine there's an arrow on the end of that as well. So here is my initial angle, and we'll call that theta. And let's do another one in blue. It would have the same initial ray. I'm just freehanding this. And it's going to have the same terminal. And you're going to go, well, gosh, that looks exactly the same. Well, yes and no. Because what's going to happen is that's one rotation and a little bit more. Okay? So that's where this comes from. If something is coterminal for degrees, you're either adding or subtracting one rotation or multiple rotations. So you're either adding or subtracting a multiple of 360. For radians, you're adding or subtracting a multiple of 2 pi. They have it written as 2n pi. I personally think of it as 2 pi n. It doesn't really matter on that one because it's all multiplication, but I think of that 2 pi as a rotation and then the n as the number of rotations. If n were positive, I'm going counterclockwise. If n is negative, I'm going clockwise. Let's work one out. So on this one, I want to identify all angles that are coterminal with 80 degrees and then find and draw one positive and one negative. So we're dealing with degrees, so let's see what that looks like. Well, here's 80 degrees just drawn out, and that's easy to picture. It's going to be slightly less than 90. It's not quite a right angle. And they give us the formula 80 degrees plus 360n. So that is everything that would be coterminal. But I want to find one positive and one negative. So I'm going to let n equal positive 1 for my positive and negative 1 for my negative. So that's going to be either 80 plus 360. That would be my positive, and that gives me 440. And then I want that negative 1 as well, which that one's not on here. 80 minus 360. And that, whoops, forgot my 6 there. I'm going to give myself a C on handwriting on that. Sorry about that. So 80 minus 360 is going to be negative 280. So if I were going to do that, that would be starting along my positive x-axis. And I'm going to my terminal axis right there. So it might take a second for you to kind of wrap your head around that. The positive angles are both going counterclockwise. The negative one is going clockwise. Oh, there's the picture. Their picture looks a lot better than mine. All right, let's do one that's got a radian. I want to identify all angles that are coterminal with negative pi over 4, and then draw and find one positive and one negative. So we're dealing with radians on this one. So our angle is negative pi over 4. So I'm going to let n equal 1 and n equal negative 1. So when I do the positive, I'm going to take and add 2 pi times 1. If you are a little shaky on fractions, you put that over 1 and you're going to have to get a common denominator. My common denominator is going to be 4. So I'm still going to have negative pi over 4. Multiply that 2 pi by 4 and I get 8 pi. 1 times 4. And that is where the 7 pi over 4 comes from. If I were to subtract, then I'm taking away 1 rotation. I'm still going to have negative pi over 4. But this time I'm subtracting 8 pi over 4. And that is where the negative 9 pi over 4 comes from. And off to the right, you can see the picture, and you can kind of visualize that. All right, go ahead, hit pause, try this one on your own. If you hit A, you did it correctly. You take 126 plus 360, and that'll give you the 486. 126 minus 360, that'll give you the negative 234. All right, one last thing that we want to talk about, and that is arc length. That is just the distance around the circle. If we took the whole distance around, that would be the circumference. But if you look at that picture, we're only taking part of it, and that is the arc length. The arc length, which is going to be S, is given by the formula S equals R times theta. Key point, theta has to be in radians. We will try and trick you every once in a while by giving it to you in degrees, and you will have to convert from degrees to radians. So let's go ahead and just do a really simple one. We want to find the length of the intercepted arc in a circle with a central measure of pi over 3, so they're giving us theta, and a radius of 4. And they're telling us to round. So we write down our formula, and we get S equals R times theta. Well, R is 4, theta is pi over 3. If we wanted it exact, it would be 4 pi over 3. I don't have my calculator in front of me, but if I wanted to round, I'd take 4 times 3.14 divided by 3. That's calculator work. I'd let you do that. Here's one that I was talking about where they're going to try and trick you. We want to find the length of an arc, and they're giving it to us at 125 degrees. And they tell us the radius. So you're going to have to take that 125, and you're going to have to convert that into radians. So to convert that 125 into radians, you multiply by pi over 180. When you do that, you're going to get 25 pi over 36. So we now know R, we know theta. Arc length is R times theta. 7 times 25 pi over 36. 7 times 25 pi is 175 pi over 36. And if I wanted to round that to the nearest tenth, take 175 times 3.14 divided by 36. All right, take a second, hit pause. Try this one on your own. All right, if you got B as your correct answer, you are good. All right, that is all that we have today. If you are still struggling, come into IPASS or come into Math Lab. Or, as always, ask a lot of questions.